All right, 4.2, building linear models from data, okay? So basically, this is where you are, you're creating your own linear equations. Hold on, my computer is doing something very weird. There it goes. So our objective is to draw and interpret scatter plots. We're not going to actually draw scatter plots. We're going to use our calculator to create scatter plots, if that's okay with you. Now, if you feel like I'm cheating you by not letting you draw, then I'm cheating you. I'm so sorry. But you can practice that at any time. Okay, so drawing and interpreting scatter plots. So when you have a linear model, that means that there's some type of correlation when you plot all the points, right? So our example here we have in baseball, the on-base percentage for a team represents the percentage of time that the player safely reached the base. The data given represents the number of runs scored Y and on the base percentage X for the National League during 2017 regular baseball season. So bam, we have all these numbers, right? Yay, baseball stats. Thank you, ESPN. We're not going to do the scatter plot, but we are going to use the graphing utility to draw a scatter plot and describe what happens to the runs scored on the base, okay? So looking at a scatter plot, if you were to actually draw this, this is what you would do, right? We would only focus in quadrant 1. Why are we only focusing in quadrant 1? Because it's real world, right? And also notice here when you're creating a scatter plot by hand, how you have these breaks in your graph. What this is saying is that there's numbers that are not being utilized. And so instead of starting at 1, I'm going to create a break and then start my pattern at a number other than 1. Does that make sense? Okay, and then I plot the points. Okay, notice that scatter plots are not connected points, and there never are, because that's why it's called a scatter plot. Now we're going to talk about how to do it in the calculator. Okay, so in the calculator, I need to go back to the table. When we have our calculator, let me screen, show taskbar, handy dandy calculatora, turning that on. I'm just going to clear my calculator. So second plus 712. And to input our data for our scatter plot, we're going to go to stat and we're going to go to edit. Okay, so once we're in stat edit, that's where we input our data. So I have 32.9, 32.6, 33.8, 32.9, 33.8, 33.4, 33.1, 32.2, 32, 32, nope, 31, 31.5, 31.8, 29.9, 30.9. Please excuse me for saying point. I know it's the tense. Promise, I do. Um, 33.4, 33.4, and 33.2. Okay, so I've put in my X's and now I'm going to put in my Y's. So I have 812, 732, 822, 753, 824, 770, 778, 732, 735, 690, 668, 604, 639, 761, and 819. Okay, so input points are in. Once your points are in, you're going to actually have to turn on your scatter plot. So do that. You press second, Y equals, and you see where it says plot 1 off. I'm going to click on that, and I'm going to turn plot 1 on. What this is doing is says, okay, so I'm turning on your plot. You want it to be a scatter plot. You want me to use your list 1 and your list 2. And I'm like, yes. Then I'm going to hit graph. Notice I can't see the points, right? So thinking about how we created our scatter plot, that means we had to change our window setting. So I know I'm at 0. And if I look at my x's kind of go pretty high. So I'm going to max it off at 35. And I'm going to count by 5s. Is that cool? My y's 0, and they go extremely high. I'm going to cap off at
Okay.
850.
Students, if you are parking across.
And I'm going to count by 50s. Graph. All right. So you see why on our scatter plot, they had that little cluster saying, oh, I'm not going to start here into there. That's where you're like, oh, my X-Men can do a little more. Let's start at 20. That's pretty low. And let's start at 600. Ooh, now I can see some more, right? I can see a little bit better. So it's about all adjusting. So now plots are here, points are here. And from here, I can describe a relationship, right? What is happening with the on-base percentage and their scoring? What do you see? What kind of relationship do you see? No relationship, a negative relationship, a positive relationship. It's a positive relationship, right? And it's a moderately strong positive relationship, right? They're all steadily increasing. So this is a better plot with the numbers. So see here, we're at 850 and 575, and then we're at 29.5 and 34. So how you set it up is going to make your image either better or worse. Okay, so then it shows what is our scatter plot shows us either way is that there's an increase. There's a positive relationship with the over time of between the two things. Okay, questions about being able to do it on a calculator or creating a scatter plot on your own? Easy peasy. All right. Next, distinguishing between linear and non-linear. So I'm going to keep this graph open for really quick. So here we have scatter plots. So if you're trying to determine if something is linear. All right, so if you look right here, we have a linear correlation, right? Steady increase, positive. Oh, pen did something real weird. Pretend that that's a straight line. So we have a positive correlation. We have a negative linear coordination. Okay, this right here is nonlinear. This right here is nonlinear. This right here is nonlinear. They may be nonlinear, but that doesn't mean they're not other types of functions, right? So like when we see here, we kind of probably see a quadratic, right? We can see that. We can look here, might kind of see a little cubic happening, right? We can see right here, it's a little exponential taking place. They're just nonlinear, okay? We're not asking what else they could be. We just know what they are not. Make sense? All right. So when you graph, when we're looking at this graph, clearly this is what? Nonlinear, okay? When we look at this one, linear. This one, okay. And this one, perfect. You understand, good job. All right. Now we're gonna talk about finding the equation. So select 2 points and find an equation of the line containing the points. Graph the line and scatter points, okay? So using our data that we already had, right? That's why I said we need to keep this. We're gonna find the equation of the line. So to do this all in the calculator, we're basically looking for our line of best fit. Does that make sense? So we're gonna go back to stat. Remember, we already put our data in, right? So we're gonna just double check that's there. You need to be on the calculator page, so the input page, and you're gonna go to stat, and you see where it says calc. That means I want you to calculate, okay? I want you to calculate, and we're looking for a linear relationship. Do we see this as linreg? Yeah. So we're gonna click on that and it's gonna like, is this what you want? Yeah, that's what I want. And then we're gonna click enter and it's gonna approximate what a good A and what a good B is for this problem. You just hit enter and it's gonna approximate itself. Okay, so let's do it again. So we went to stat, calc, and then we look for a Lin regression. We clicked on it and we clicked enter for it to tell us what our approximate values are. Okay, if you want to have this rounded before, then you need to make sure you change your mode. So if I wanted to have to the nearest tenths or hundredths, I would make sure that's set. And then when I go to stat, calc, and go to linear regression, it'll round the numbers for me. Okay, so now I have an equation that I can plug in and see how closely it works with my points that I have. So we have A, which is our slope, is 57 and 3500ths. And B, which is our y-intercept, is negative 11, 20, and 7500. So we're gonna go to y equals, and we're gonna input that. So we have 57 and 3500ths x minus 1120 and 7500ths. I hit graph. And I let it think. I'm gonna adjust my window a little bit. I forgot what the other adjustment was. What was it? Was it at 29.5? Counting by, we were at 35. And we're at 1. And this one was at 550. And I don't remember what it was counting by. We'll see. So there's my graph. So I'm looking for my y equal. I promise you guys that the y equals should be there. I don't know why it's not. What? Hold on. I know I have a picture of this. Okay, so that's what's supposed to happen by hand. So you find the slope, we use the numbers, we plugged it in. Got it, got it. Have our diagram. Not right now. Oh, yes, right there. Thank you. Put it in. On the newer models, it tells you whether it's a good fit or not. So if you look at your R, notice how our R is very close to 1. R being close to 1 means that it's a good model. We still got the same numbers. We plugged it in. Why is my graph not showing? I did it already once. I have no clue why my graph is not showing for y'all. I don't know what I did. This is the type of plots. That's gonna do that. That's definitely not what we want. I did it on the computer and made that, and that was fine. Anyone knows why my graph is showing? Nobody? Okay, it's cool. I'm gonna figure it out. I promise this has not happened before. Let me turn the plot off and see if it'll show my graph. Plot off, and then hit graph. Okay, let's go back to the standard window. Standard. I don't see anything then. Zoom fit. That's definitely not the way it goes. Oh, guys, I'm a special person. I put a negative instead of a minus. I was like, what is going on? This is called trial and error. Don't give up. Don't be a quitter. All right. Let me put my Windows settings back how they were. So I was at 29.5. and I went up to 35, counting by ones. Here I'm at 575, up to 850, and I counted by 50s. Oh, did no one see that I chose that? I promise y'all, I was like, I know that I know what I'm doing. So yeah, so there's my line, and you can see that the line at best fit is the line where the points are the least distance away from that, right? Where all the points are the least distance possible. And that's how you do it, okay? Fairly easy. Hopefully you feel like that's doable. All the instructions are here. And so our slope was 57 and 3500ths, which means that for every 1% increase on the base percentage runs, they will increase their score. And so then it asked us, well, what about other values? So now that I have a table, could I estimate anything else? So if it asked me, what if a person has 34? I'm going to put in 34. So I hit second, and I'm going to find a value. And I want 34. Hit enter. And it says 34 is roughly right here, 829. Or like the problem, 33.2, 33 and 2/10. That's going to give me roughly 783 based on our model. Okay. But yeah. So it's a pretty nifty little thing to do with the calculator, and hopefully you're okay with it. So that's 4.2, modeling via technology. Questions about modeling with via technology?